Greetings, folks, and welcome back to Femboy Mathematics. I'm sure you're Femboy, and today we're going to be talking about functions. Or this episode, rather. It's not really day right now, it's night. But today we're going to be talking about functions, or as they're denoted as f of x. Now, functions are basically a notation for a certain equation or expression that we're in. If you find the function of a certain number, it's gonna put that number into that. It's basically a machine that gets your input and spits out an output. So you can think of it as a machine. Wherein it takes an input and spits out a different number, y. So this is how a function basically works. And the function can basically be in the form of an equation, or it can be in the form of an expression. Now, a function is mostly the widely common way of denoting functions is via f of x. But my teacher actually denoted it as y equals that equation x squared, or something, any equation or any expression to express your function. So how do we evaluate functions basically? Let's say we're given f of x. Chickens. Okay, let's say we're given function f of x equals x squared. And we're told to find the function of 4 equals x squared. What do we do then? So basically, we just replace x or all x values in this expression with 4. So this would simply be f of 4 given f of x would simply be 16 because 4 squared is 16. And same would apply if we're given f of x equals x squared minus x. So let's say we're gonna find the function of 6. That would be 6 squared minus 6, and f of 6 would simply be 36 minus 6, which is 30. So that's how you evaluate functions. Now, another thing about functions is that you can graph them. You can graph functions. Now, I'm not really going to be discussing it here in this episode. I suggest you just search it up on the internet. But the most common way is to draw a table of x and y values and then, apply the function to every single value from 1 to a certain number and then just graph it from there. But I suggest just searching from different videos at this point. So, with that, next I'm going to be talking about functions and their transformations. Let's say we're given a graph. X squared, f of x. We're given a certain graph f of x. Now, there are these things called transformations to a graph, wherein they're either moved on that plane or on this Cartesian plane here, either they're moved, translated, or scaled, or stretched, or compressed. Now, there are different types of transformations, and they are dependent on the operations that you do in your function. So let's say we have f of x, and we have our given x value x. What do you do then? Right? So x is just your normal function over here. And if we add something to that, x plus k, what we're doing is basically translating it or moving it to the left or right side. So this would be the same function, but we moved it k units to the left since it's positive, and if it's negative, it moves to the other side. You already know that, or you should already envision that or have a good intuition on it. Now, what about and there are actually specifics when it comes to doing these transformations. So let's have our Cartesian plane again and our original graph f of x. And let's say we encase these in parentheses. So if we encase it in a parentheses, this over here this tells us that the translation of the graph is going to be horizontal, or it's going to be in the y values. It's going to translate in the y directions, so either here or here. But if we add k on the outside of a certain of the function encased in the parentheses, let's say b, then it is translated horizontally on the x plane. So it either moves down or up. But if it's inside the parentheses, it moves left or right. It's not the correct orientation or the correct order, but eh. Now moving past that, what if we're scaling x? Now I'm gonna be discussing more about scaling and scalars and vectors in extras episodes when it comes to Femboy mathematics. So I'm just gonna be discussing it here, but not really. Today we're focusing on functions and their transformations. What if we're given something like f of x equals kx, and k is like a certain any integer you want. So basically, what we're doing with k is, or what we're doing with the graph, this is f of x, the original graph, is basically we're either stretching or compressing it by k units, or basically we're multiplying the graph such that every value would be exponentially grown. So it would either be like this, or it would grow like this, or it would shrink like this. That would be times negative k, or actually not really negative, but rather half of k, and this one would be by k itself. Now what if we're given something like a negative k value? What if we're given a negative integer value or coefficient or scalar or scaling factor in this function? What if we're given something like negative k of x? So right, that's our, let's say we have our function here, our original parent function f x with just x itself. What if we have k in it? It's basically, if you're given a negative value, if we're making it negative x, we're flipping it, make it go the other side. We're flipping it like this and scaling it by the factor of x. And same thing applies with different graphs. Let's say we only have a graph from around, let's say we have a graph from only 1 0 to a certain number in infinity. What if we're given something like this, like from 0 to infinity? If we're given a negative x, it would flip over, it would mirror in that same plane, so it would mirror on the x direction, and the one a while ago was mirroring on the y direction. So that's pretty much almost everything you need to know about functions. It's not really everything. I suggest you search more about functions before jumping to the next one, which is gonna be summation notation. So until then, I'm gonna see you guys in the next video. So I'll see you guys then. Ooh, ooh.